went well.
It was good. All the exams?
Yes, ma'am.
And Hamza, what about you, Hamza? How was your exam, Hamza? Priya, I think we had a talk on WhatsApp, no? Priya Darshini?
Yes, ma'am.
All right, class. So, see, I'll be starting with electrostatics today. So, how will we go is first we'll try to cover Coulomb's law and electric field in today's class. We'll then try to cover electric dipole and Gauss law in tomorrow's class. And on Tuesday's class, one class that will be left for Gauss theorem. This will be, we'll cover electric potential and capacitance. Fine. So, let's try to finish Coulomb's law and electric field at least. This is also a very heavy portion from your syllabus. Now, before we start directly with the numericals, it's better at least let us just revise few theoretical points, because your statement-based questions will also be there. So see, all of you have already studied all these theory points, but let us just quickly revise it. So under your electrostatics, you have two chapters basically. So electric field and charges is already there, electric potential and capacitance is there. So from electric field and charges, electric charges and field, electric charge is a very basic term that all of you are aware of. It's an intrinsic property of matter and it gives rise to different phenomena. Electric force, you know, electric field, you know, right? So all these basic, then you have electric potential sums up, then this charge ultimately moves and leads to the formation of electric current and all these, right? So electric charge basic SI unit Coulomb you should remember, and CGS unit electrostat Coulomb you all should remember. So two types of charges exist. One is a positive charge, second one is the negative charge. This is very basic. Now what you have to remember is that it's the transfer of electrons that occur. See class, electrons and protons both are present, right? Protons are present in the central core of the nucleus, right? And electrons are revolving around the central core. So which quantity is moving that is leading to the formation of a positive or a negative charge, right? We have positive and negative charges. So how are we calling a charge or a body as positive or a body as negatively charged? So that just depends upon the transfer or movement of electrons. Protons do not move. Reason behind is that protons are held through tight nuclear forces, right? These nuclear forces are very strong than these weak electric forces. While these electrons are moving around the protons with the help of electrostatic forces. Two forces are existing within your nucleus, which you have to be aware of. Other forces are also there, but you can neglect it. Protons are held through strong nuclear forces. Electrons are moving through weak electrostatic forces. If the nuclear force is stronger than the electric force, it won't allow the proton to move. It will hold the proton tightly. So it's actually the transfer of electrons that occur. Electrons get transferred. So if I have two bodies, let's say these are two bodies. From this body, some electrons have moved into this second body. So what will happen? From the body which the electrons have moved, the body that has lost the electrons, this body. Now this is what? Deficiency of electron. We'll call this body as positively charged. So it isn't the addition of protons that made this positive. It's the deficiency of electrons that made this as positive. And what will happen to the other body? This body will be gaining electrons that has been lost. So if it is gaining electrons, now what will happen? Negative charge will be dominating, right? So this is how we differentiate a body as positive and negative and the types of charges and their basic properties. Now, I just simply said that 2 electrons are moving, 3 electrons are moving, 4 electrons are moving. But there should be a mechanism, no, by which these electrons, these charges are moving. So that transfer of charging, transfer of the charge, we call it as charging. Simply, if the term charging is mentioned to you, understand charging simply means that transfer of electrons. So instead of writing the whole statement, transfer of electrons, charging can also be mentioned. So basic 3 types of charges you have in your system, 3 types of methods of charging. That is charging by friction, charging by conduction, charging by induction. These 3 you have. Now frictional force you already know. So from friction force that you know, this is the same friction force. Suppose because of rubbing of two objects are getting rubbed. So what will happen? Friction force will get generated because of two irregularities getting in contact with each other. Friction force will get generated. So since two bodies are getting rubbed, that will lead to the transfer of electrons. So this is one method, charging by friction. You don't need to go into the details of charging by friction. Nobody is going to ask you specific questions on charging by friction. It's just that you have to be aware, and this is simple. Charging by friction means simple transfer of electrons from one body to another. So that is very basic. Charging by conduction is important because in charging by conduction, see, under charging by conduction, two bodies aren't rubbed against each other. In friction, we had the bodies getting rubbed. No. In charging by conduction, you just place both the bodies in contact with each other. Just in contact with each other, and the charges will get transferred. No rubbing occurs, but they are placed in contact. Now, why this topic is important? Because if the two bodies become identical, right? If let's say both bodies are identical, how can we say two bodies are identical? If the radii of the spheres are equal, right? If the length, or you can say the side of the cubes are equal. So this is how the two bodies become identical. So similarly here as well. If two spheres are identical, means both of them have the same radii. In that case, charge gets equally transferred. And that is the key point for your numericals as well and theory part, right? So if the bodies are identical, directly divide the charge into two. Fine. For example, in this also, the example which is written here, 4 electron is present on one charge, one body, and 0 electrons, no charge is present on second. So how will we divide it if they are equal? So simple division is that total charges are 4 electrons. Two bodies are there, each will receive 2 electron each, right? So that is charging by conduction. Then you have charging by induction also. See, in induction, this is not very important from your JEE perspective, but charging by induction, you don't have to specify it, but in numerical form, it can be mentioned. Otherwise, separately, it won't be. Now, see, in charging by induction, what is meant by this? Suppose a body is there that is having both positive and negative charges, right? I have brought a glass rod, which is containing either of the charges, let's say positive, the way it's written on the screen. So what will happen? All the negative charges will get attracted towards the one end of it. See, here, this edge, all these negative charges, these are getting attracted towards one edge of the body. That is, all these negative charges are getting accumulated at the near the glass rod. Glass rod is positive, this is negative, right? So positive glass rod will attract all the negative electrons. Rest of the positive charges now will get accumulated on the other end. So we have successfully separated the negative and positive charges. That is just known as charging by induction. So you have these three phenomena: charging by friction, charging by conduction, charging by induction. That's all you have to remember about the basics of charges. Theoretical portion can be asked from this because numericals are not usually asked from this topic. Theory points can be asked. Statement 1, statement 2 can be given like this, or 4 statements will be given to you. Options will be in such a manner: A, B, C are correct, A and C are only correct, in this manner. So from this you have theory part. Then you have a very important law, that is Coulomb's law. So Coulomb's law, all of you are aware of, a very basic law. So what is the statement of this law? See, two charges are present, charge 1 and charge 2. They are separated by certain distance, right? So very, very basic law, this says that the force that will be present between these two charges, both the charges will be executing some force on each other. So the force's magnitude will be directly proportional to the product of the magnitude of these charges. Means Q1 is having, let's say, 2 coulomb, Q2 is having, let's say, 4 coulomb. So force will be directly proportional to 2 into 4 coulomb, right? It will be directly proportional to 2 into 4 coulomb, because product of magnitude of both the charges. When I say magnitude, do not consider if it is given -2, so you will write minus. No, magnitude means you are eliminating the signs. Whatever signs are present, you're just taking out the number and multiplying. Even if you have -3 coulomb, -9 coulomb, +3 coulomb, +9 coulomb like this, do not consider the signs. Just take out the number, multiply, that will give you the product of magnitude of the charges, right? Easy. Now, second statement is that this force is inversely proportional to the radius. That is the separation between the two charges. So that forms your law as F is directly proportional to Q1, Q2 by R square. Here you get a constant. So your Coulomb's law is F is equal to 1 by 4 pi epsilon naught Q1, Q2 by R square. Right? Now the constant is 1 over 4 pi epsilon naught, which we write as 9 into 10 to the power 9. These values you all should remember. And I hope you all remember these values. K, a value of epsilon naught, permittivity, right? So 8.85 into 10 to the power minus 12 is the value of permittivity for air or vacuum. That is absolute permittivity, right? You're not considering any other medium here. No other media has been considered here. Water, nothing. You're just taking absolute permittivity means air or vacuum. So whose value you have to remember this value. Right, so all these points are very basic. From this topic, what is important is, these are simple laws. This part, this is important class. Epsilon is permittivity in any medium. Permittivity means what? What is the meaning of permittivity? Permittivity means how your force is changing with respect to different media. Suppose I've taken these two charges and I've kept these two charges in air. So some value of force I'll get. Then I put these charges back into water. I'll get some other value of force. So what is the interplay or this governance is basically taken in charge by the absolute permittivity. Fine. So if it's some different medium, some other medium, we'll say epsilon. If we are talking about specifically air vacuum, epsilon naught. And their ratio will give you relative permittivity. So what you have to remember is whether it's epsilon by epsilon naught or epsilon naught by epsilon, that becomes confusing. So remember, it's always medium by air for permittivity, but it becomes exactly opposite for force because this is in the denominator. Force is inversely proportional to epsilon naught. That's why for force you have, for K value, you write as this value of K constant is given as F naught, that is force in air divided by the force in medium. Whereas for the value regarding the epsilon, that is the permittivity, you write epsilon by epsilon. That's it. That is sufficient. The properties, the rest of the details of it that you all can manage, right? Before we do electric field, let's practice some questions from Coulomb's law, right? So I'll start with at least first 2-3 questions. We'll take very basic questions. Do one thing, note down this question first, then I'll discuss it. Just note down this question. 2 identical tennis balls are having mass M and charges are Q. They're suspended from a fixed point, length L, equilibrium, separation. Just note it down. I'll just explain this. C class. This is actually one of the easiest question that have come in your JEE. Right, a very standard basic question. So I think this is a question from 2021's paper only. So two identical tennis balls, each having mass m, charge q, are suspended from a fixed point. A fixed point is there. So obviously, if they are containing charges, they'll repel. If you take a thread and hung two balls, and they are having, both the balls are having same charge, they'll repel each other. So they'll get apart. So how will we represent it? And this is class, do this. Why I'm starting with this question is that because it's a very basic question for the questions related to this, because many questions have come related to this with just slight modifications, right? So see, a fixed point is there. So this is the vertical. Now both the charges have separated. Both the charges have been separated. Now this is theta. This is theta. This is written as, I think, L, and this we have that both the charges are as Q. Length of the thread is L. This is all we have. Now what we are going to do? Of course, forces will be applied. Both the charges are getting separated. So one force will be away from the charge because both the charges are having the same charges, right? So the force will be moving away. One very basic force. What all forces will come? Yes, class. Any other force you think apart from this electrostatic force? Or only this
Tension.
force? Yes, Krishna?
Tension.
Tension, right. String, since string is there, tension will also be there. So this will be tension. And any other force?
Weight of the charge.
Correct. That is mg will be acting downwards. So these are very basic forces that will act. Now, just one problem in this figure is that we always have to resolve the forces along x and y planes, right? X and y axis, except for your inclination from your Newton's laws of motion you have. When you have inclined plane, then you take it perpendicular to the plane. Apart from there, in whichever topic you're studying, whichever topic has been discussed, just remember, always resolve the forces along x and y planes. So only tension is not acting here. So we'll resolve tension. If this is theta, these two lines are parallel. This will act as a transverse. So this will also be theta. Now I'll resolve this. Since this is the force, this is the angle. The axis with which the angle has been made, that always becomes cos theta. So since the angle has been made with this axis, this y1, so this becomes t cos theta. And this will become here t sine theta. Fine. This is how we'll write the forces. And let's say if the separation between the two charges is small d. So let's write Coulomb's law of force. At least let's be free with that. So what will be the value of force? K. Now Q1 into Q2, both are Q. So Q into Q, that becomes Q square divided by inversely proportional to square of separation between them. So that becomes d square, right? Now, apart from this, we have certain forces which are equal to each other. This is from Coulomb's law. T cos theta is balancing mg. And this force, electrostatic force, is balancing T sine theta. Then only the system is in equilibrium. That's what we have from our knowledge, that these systems are in equilibrium. So until and unless these are in equilibrium, this will be this one. So it means F will be equal to T sine theta. And what is left? Divided by mg, we have this equal to T cos theta. So tension gets cancelled. Sine theta by cos theta becomes tan theta. Force's value, write the value of force from here. That is K Q square by D square, right? This is the value of force that I have written, and mg will be there, right? D square, KQ square, D square by mg. Now from here, what do we have to find out? Separation, no? We have to find out D. So yes, our answer is ready. See. This is tan. Acha, one more thing. Tan theta also we have to eliminate. No, tan theta also we can eliminate from the figure. So see, tan theta for small approximations, I've always told you for small angle approximation, tan theta will always be equal to sine theta, which is equal to theta. Fine. Tan theta and sine theta you can equate for small angle approximation. So what will be here? Your sine theta or tan theta. This is sine theta. This will be equal to simply D. This whole separation is D, right? This whole complete separation is D. So this part will become D by 2 only. So 2 will go up. That becomes D by 2, right? D by 2. This is half part. D by 2. And this is L in the denominator, right? So now put this value. We'll use this value to find out. So this is tan theta. Instead of tan theta, you have square. Square it up, you get D by 2L. This is equal to KQ square by D square mg. Now we'll square it. So that becomes, this is D square. So this becomes DQ mg is equal to, both these terms will get multiplied, KQ square to L, right? This is what we have. Put in the value of K also. In your options, no, I haven't written the options here. It was given in terms of epsilon naught and pi. So it's better if you write K fully. So that will become K. We know that is 1 over 4 pi epsilon naught. So write the complete value of K. So from here you have the separation. So D square will be equal to Q square L by 4 pi epsilon naught mg. From here D will be equal to under root, or I'll write to the power half. Fine, class. Now we'll see some more questions from this topic, but before that, just quickly note down the solution. Then some more questions we'll see. So these thread questions are very basic.
Ma'am, it should be D cube, right?
Where, Krishna?
I mean you wrote d square is equal to q square L by 4 pi epsilon naught. It should be d cubed, right?
This part, q square L by 4 pi epsilon naught mg.
Yes, ma'am.
Yes,
It's
1
cube
by,
root.
yes, cube root. Right. This will be 1 by 3.
Ma'am, will it not be 2 epsilon naught?
Yes, see, if we'll write here 2, it's better, let's directly write it in the denominator as 2 epsilon naught only. Otherwise, 1, 2 will be there, 2L will be there. So you can write in both the ways. If we are eliminating 2 here, this is 2L. So the q square by 2L, here we can directly write it as 2 pi epsilon naught mg. I think in your options, 2 pi epsilon naught mg was only there. So it's better if we write 2L by 4 pi epsilon. So 2 and 2 will get cancelled like this. So just note down this question. Try it once also. This is also not a very difficult question. Just try it. Send me in the chat box, send me the options. Do not write the whole term, A, B, C, D, whatever option you are getting correctly, just mention me in the chat box. Take 2 minutes and I'll discuss it with you. See, so it says that find out the surface charge density at the intersection point. So x is equal to 3 meter is given to you. And what else is mentioned? Uniform line charge of 8 nanocoulomb per meter. See, how will we solve this? This is also a question from your 2021's only, I think March shift paper. So see here, what all things we require from this question is that lambda is given to you. What is the value of lambda that is given? It is 8 nanocoulomb per meter. So we'll convert. If it becomes confusing, no, go through the charge. Just look by the unit. Like here, coulomb per meter, nanocoulomb per meter, charge by length. So charge by length, that you can easily figure it out, right? So this way you can go along. So linear charge density, this is given as 8 nanocoulomb per meter. That is equal to 8 into 10 to the power minus 9 coulomb per meter. Now, there's a relation between the surface charge density and linear charge density. How will we write it? See, 2k lambda by r, right? This is one value which we write it as equal to epsilon naught, sigma by epsilon. Just remember this relation for all of your numericals, this relationship between lambda and sigma. Right? This you can derive it from your electrostatics Gauss law only, but just remember this law wherever lambda and sigma are mentioned together in a single question. Now it's a very easy question. If you know this, see, K is what? K is the Coulomb's constant. Lambda is linear charge density. Sigma, this is surface charge density. R is the radius, distance basically. And epsilon naught is absolute electrical permittivity of free space. Now from here, you only have to find out sigma, right? Rest of the things are mentioned. So sigma will be equal to 2k lambda epsilon naught divided by r. So you just have to put in the values 2 into k. K is 9 into 10 to the power 9. Lambda is given as 8 into 10 to the power minus 9. And then epsilon naught 8.85 into 10 to the power minus 12. This whole term will get divided by r. That is the separation, which is given. X equal to 3 is mentioned, no? X equals to 3 meters. You will just write it as 3. So once you will solve it, you will get it as 4.24. Yes, correct. So Adriel has already answered it. A part. Good. Correct. Newton Coulomb per meter square. That is your A option. Note it down, note the solution. Some other questions I'll write and practice that. class, this is a completely theory-based question, assertion reasoning type in the form of statement 1 and statement 2. So this won't take time. Just note it down and send me the option along for which you think it's correct. So last question, I think only Adriel answered. Others also try this time. Just send me the option number, A, B, C, D, whichever letter is correct. Priya, write the reason also. Apart from Priya Darshini, others, Aditya, Hamza, Adriel, Krishna, which option you think is correct? Okay, Krishna has answered. Krishna, Priya. P class, statement 1 says, for a charged particle moving from point P to Q, 2 points are there, P to Q. Net work done by electrostatic field on the particle is independent of path connecting point P to Q. So if electric field is which type of force? It's a conservative force, and conservative force do not depend upon the path. So statement 1 is true. It means you have already eliminated D option. Now what are all are possible? 1, A, B and C, right? What is the second statement? Okay, Hamza. See, second statement says that net work done by a conservative force on an object moving along a closed loop is 0. Right? Correct. When the net work done by conservative forces, if it's a closed loop, closed cycles are there, we always write the net work done 0. For an open loop, we do not equate it to 0 directly, but for closed loop, we write it to equal to 0. So second statement is also true. It's independently true. Right? Statement 1 is also true. Statement 2 is also true. But see, is 2 explaining 1? For charged particle moving from point to Q, net work done is independent of path. So is it independent of path because work done is 0? Is there any relation between this? See, if I say the statement, tell me, is it right or wrong? For a charged particle moving from one point to another, work done by electric field is independent of the path because conservative force moving when the object is moved along a closed loop is 0. There is no correlation between these two statements. No, since the force is along a closed loop is 0, that's why we have electrostatic field independent of path. This is not correct. Yes, electrostatic field, since it's a conservative force, electrostatic field is a conservative force. So this will definitely be true. And net work done along a closed loop is also 0. Because work done by conservative forces does not depend on the path. That's why we have statement 1 correct. And when we have the net work done, when we are specifically talking about a closed loop, that is 0. But this is not the explanation of it. So which option do we have? B option. Right? Because it's not explaining it. One more numerical we'll do, then we'll move on to electric field. One last numerical. Yes, question. Note it down. Try it by yourself. Tell me which option is right according to you. I'll discuss it. At least note it down. Try it. This is not very difficult. It's just that one hint which you can start is that draw the force's direction. Then only it will be easier. Class C, how to start this? Draw the forces. As I'm telling you, it's better if you will draw all the forces. See here. Minus Q1 plus Q2. Opposite charges are there. The forces direction, this F12, this will be here. Attracting. Plus Q is there, minus Q1 is there. It will move, okay? Force will be attractive force, right? Now, minus Q3, minus Q1, both are negative, right? So what will happen? It will push it away. Both the charges will move away. So this will be, this is not Q, this is theta. Sorry, class. This is theta. Fine. So this is minus Q1. So this was F12. This is F13. Fine. If I'll drop the perpendicular, this part will also become theta. Now see, all your question will be solved from here only. Look here, class. This is what you have, right? Now see. Okay, Priya. Others also try to answer. All those who have solved it, at least send me your answers. Okay, Priya. See, I'll resolve this F13 because F13 is not getting aligned in X or Y axis. This part which is making angle with the axis, that is termed as cos theta. So this will become F13 cos theta. This part will become perpendicular. This part will become F13 sine. So what will be net force? The net force will become F12 plus F13 sine theta. Now just write down the magnitude of it. What is F12? This is Q1, Q2 separated by B. So that will become K. Right, here we have K. Q1 magnitude, that's why I'm not considering minus Q1. Q2 divided by B square. Okay, Adriel has also answered. Adriel and Priyadarshini. Plus F13. See, F13 is minus Q3 and Q1 separated by A. So that will become K, Q1 and Q3 separated by A square sine theta. K will become common. That is Q1 and Q1 will also give. K and Q1. K, Q1 will be common. From here we have Q2 by B square plus Q3 by A square sine theta. This is your force along x-axis. X-axis only, no? It has been asked in the question. So your f-axis is directly proportional to Q2 by B square plus Q3 by A square sine theta. So which option is matching this? B option, right? This is B option, no? So I think already Priya and Adriel have answered it correctly. Good. This is B option. Note it down, then at least some questions of electric field we'll discuss. So I hope this question is clear to others as well. Aditya, Hamza, Krishna, correct. Is it fine by all of you?
Yes, ma'am.
See class, at the center, you have to find out the electric field's value. So 1, 2, 3, 4, 5, 6, 7, 8. 8 charges are given, right? Minus Q, 2Q, plus Q, 2Q, 2Q, Q, and minus Q. All these charges are given to you. So see, at the center, if you have to find out the electric field, what will happen? For the positive charge that is given to you, that is plus Q that is given to you, the charges will get attracted. So electric field will be in this direction, right? Electric field's direction will be this. One more thing, I think this minus, this is plus 2Q. So yes, this is plus 2Q. So electric field's one direction will be there above. Now what will happen? Then again you have minus Q. So because of minus Q, here also you have minus Q. Both the electric fields will be one. For this, it will get attracted. For this, it will also get attracted. For this positive charge, it will move away. Same thing. This is also plus 2. This is also plus 2. So same way for this also, plus Q, it will move away because of this. And because of this plus 2Q, it will move away like this. So this is how the electric fields will be. Fine. Negative attracting. This negative attracting, because of plus 2Q, it is moving away. Because of this plus Q, it is moving away. Similarly, for these 2Q, even if it is not written no plus, by default, it is positive, right? Now, values of each of these. C class, for these, it is very easy. Q is given. So electric field at this particular point, this will become very easy class. See here, this is simply E is equal to KQ. This is Q, right? From here, KQ by L square. Similarly, for this also, it is very easy. Electric field is equal to this part. Electric field will be K2Q divided by L square. Similarly, for this part also, it is very easy. E will be equal to K2Q divided by L square. This part also, it is direct simple. E is equal to KQ divided by L square. These 4 values we have. What about these values? What will be this separation? If this is L, this is also L. Yes, class, tell me. How much will this will be?
L root 2.
L root 2. Root 2L. From your Pythagoras theorem, this portion will be root 2L. So you have to write down the root 2L in the denominator. Do not write it as L only. So this part, class, this separation, this will become root L. Similarly, this separation, this will also become root L. 2 root L, sorry, not root L, root 2L. Similarly, this also separation, this will become root 2L. And this separation also, this will become root 2L. Now you can write down the values of electric field for this also. So now I'll write it down separately because otherwise. So one we'll have this as KQ, first one. Root 2L was there. So that becomes root 2L whole square. So this becomes KQ divided by 2L square. L square. Similarly, for the other charge that was given us plus 2Q or what? This is also same. Okay, same. For that also, let's say E1, E2 will also be KQ divided by 2L square. Fine, that will also be KQ divided by 2L square. Similarly. Then the other charge. So these two we have written. So how many charges we have? 1, 2, right? This is done, this is done. And then rest these three. E is equal to 2QC. Rest of these E3, which is equal to this. This you already know. K2Q by L square. Similarly, E4 is also K3 by L square. E5 is also K2Q by L square. Now, what about the charges that are kept beneath? This one. So again, 2Q is there, separation is root 2L, right? This is 2Q this time. This becomes, electric field will become K2Q divided by root 2L whole square. That becomes K2Q divided by 2L square. That is KQ by L square. This is E6. Then E7 is what? This is KQ by L square. This is KQ by L square. And finally, E8. All these 8 values we have ultimately. 8, I think, is also solved. Okay, this is also similar to these only. KQ by 2L square. This will also be KQ by 2L square. Why it will be KQ by 2L square? Because root 2L whole square will give you this one. Now, net electric field, main work is net electric field. So see, 2 electric fields are present above, 2 electric fields are present below, 2 on sides. Look here. Look here. Now, electric field that is going below, this electric field, and the electric field that is present above this, their resultant will give you one electric field, right? And similarly, this electric field's value and this electric field's value, their resultant will give you the net electric field. Rest all electric fields are getting cancelled, right? So only these are left. So there, this and this. So if I'll write, let me write this separately. Look here. So E net will become what? Net electric field. E that is going below, downwards, it was KQ divided by L square. A square minus B square, we write it like this. So this is the difference between the two, plus the next one, KQ by L square under root. So when you solve this, this will become KQ root 2 L square. So your answer will become, this will be, if you write down the whole value, KQ root 2 L square. So that you can write it as 2 root 2, you can write same thing, 2 root 2 divided by L. If you multiply it divided by 2, that will become 2Q root 2 divided by 2L square. How did we reach this step? 1 or 2 steps I have eliminated. I hope you have understood that step. See which steps I have eliminated. Look here, class. Electric field that is going above, this one. This electric field. Look here, class. This electric field, this one. This electric field, this electric field. Both these electric fields are getting subtracted. So K2Q by L square minus KQ by L square will give KQ by L square only. One vector we have, let's say downward direction. No, it will be upwards. Magnitude is high. No? Let's say this is upwards. Fine. Similarly, KQL square. Here you have K2QL square. When you will subtract, that will give you KQL square, which is along this direction. So here also you are getting KQ by L square. Here also you are getting KQ by L square. So when two vectors are perpendicular to each other, how do we write the resultant? A under root A square plus B square. So that's what I've written. Under root A square plus B square. One square will be here as well. And to match with it, see, this wasn't matching with the options that were given. So to match with it, I had multiplied it with 2 and 2 in the numerator and denominator. So this will be the answer.
Sam, there was one more force diagonally, right?
Yes, those forces have cancelled each other. No? That's what I'm saying. Diagonal forces have cancelled each other. Now, which forces are left? These, which forces are left? See, what was the question? Here it is asking you, what will be the magnitude of electric field at O? Each side is given L and which is perpendicular to you, right? So that was what was given to you. So you have 2Q, you have Q, you have Q. One more. Fine? Like this. So ultimately you are left with 1, 2, and 3 force. Then you will resolve it and you'll get it only. Right?
2Q and Q won't cancel out, right?
Oh, yes. This is, sorry, just a second. This is actually Q. This is Q. These forces are getting cancelled. This is Q only. The diagonals ones will now cancel, right? Q, Q, and minus Q, minus Q. So those forces are getting cancelled. I think in the calculation part also I've written 2Q only. Yeah, I've written it 2Q only. So Q, Q diagonally, they'll cancel each other. Minus Q diagonally will get cancelled. 2Q, Q is there. Q and 2Q are there. Had it been 2Q, 2Q and QQ, then the net resultant electric force would have directly been 0. But since this is having certain value, 2Q is coming with Q, then we are getting some value here. Otherwise, the rest electric field, net electric field would also have been 0. Clear?
Yes, ma'am.
One last graphical question we'll see. then I'll stop. One more thing. In the previous question also, even if it is 2q given, then also 2 will get cancelled, right? I think even if it is 2q, QQ will get cancelled. No, same answer we will get, right? No. This will become, if this is 2q, then we have KQ square by L only. Okay, KQ by L square. So it has to be Q. If it is 2q here, the way Krishna you were asking, then it won't be equal. It won't get cancelled. See some graphs I'll draw. I'll not write down every complete statement. Note down the graphs. Tell me quickly. It will just take 1 or 2 minutes for you also to answer. Please see the graphs. See, the question says that particle of mass m, charge q is released. So see, if it is released from rest, let's say this is the charged particle q having mass m, this is released. So now force F is equal to QE will be acting downwards. Electric field is, let's say, these are the downward electric field lines. Suppose. Now acceleration will be what? Acceleration will be force by mass. That's how we write acceleration. So, and force is given as QE. So QE by M. Now, if you use your kinematics equation, V square minus U square will be equal to 2AS. This is how we write it. Now, initial, this is given at rest. So your initial velocity will be 0. So this will only be V square is equal to 2AS. Acceleration's value, write it from the graph. So this becomes V square equal to 2 acceleration, that is QE by M. And the separation means the distance here is x-axis. So V square is equal to 2 QE M by X. Fine. So this is V square equal to 2 QE by M X. V square is equal to 2 QE by MX. If I write this, all these terms together, look here. This is how this can be written separately. Now, even if I write this 2 separately, right? So V square is equal to 2 QE by MX. So this equation is resembling what? This equation is exactly resembling your equation of parabola. What is the standard equation of parabola that we write? Y square is equal to 4AX that we write, right? So it means from the graph, which graph? Yes, class. Which graph is now resembling your parabolic equation? Y square is equal to 4AX.
C.
C. Correct, Krishna. This is exactly resembling your equation. Y square is equal to 4AX. Correct. Had it been X square equal to 4AY, then your answer would have been B. Right? Some of you were answering B. So had it been X square is equal to 4AY, then your answer would have been B. Yes, Hamza, C. Correct. So I think you have written the graph. No? Quickly note down this part. Just text me done once you have completed, then I'll stop the class. Rest dipole part and Gauss theorem we'll complete it tomorrow. All those who have completed, you can leave now. Rest we'll complete tomorrow. Okay, thank you so much, class.